This is a very simple experiment you can do on center of mass by just using a ruler. We're also going to use 2 coins, whatever coins you want. So what you're going to do is you're going to take the ruler and we're going to try and find the center of mass of this ruler. Now, to find the center of mass of an object like this, what you're going to do is you put your 2 fingers out and then you move them together. And then as you come closer, you'll see that the center of mass of this ruler is at 15, which is what you'd expect because the ruler is pretty much the same thickness straight through and it's 30 centimeters long. So you'd expect the center to be at 15, which you can see it is because it balances on my finger. Now what we're going to do is we're going to try something else to see if we actually added a little bit of weight to one side. How does that change the center of mass? So what we're going to do is we're just going to pick a 10 cent and then we're going to place that up at the 30 centimeter mark. So now when you put your 2 hands together, you should see that the center of mass now has changed to somewhere around 18. So it's gone this way. Is that right? And if you wanted to do a little bit of science, you could actually figure out what the 10 cent weighed by how much it's moved. But we're not going to do that in this video. So let's just compare that with the 20 cent. When the 20 cent weighs a little bit more than the 10 cents, so we're going to place that in the same place. So it was at 15 with just the ruler. It went to 18 with the 10 cent. So now what we're going to try and do is find the balancing point or the center of mass of this thing, and you can see that it's now about 19. So you can tell that the 20 cent is a little bit heavier than the 10 cent. Now what we're going to do is a nice thing you can do is to try and have a race. So you put your 2 hands out like this with your thumbs down. Now you're going to race to see, well, if I put my 2 hands at 0 and hands at 30, they come together at the same time. So they come to 15 at the same time. But what happens if I move this hand to, let's say, 10? So this one only has to go 5 centimeters to get to the center of mass. This one has to go 15 centimeters. So it's like a little race with your hands. Now, you would kind of expect this one to win, but that's what I would expect because it has to go a shorter distance. But what you'll notice is when you move, this hand does not move. So you can move this hand very freely. I'm trying to move that hand, but I can't. So this hand will only move when I get to about 20. When I get to 20, then the 2 hands come in. We'll do that again. So I'm going to leave that at 10. And now I am trying. You can try this at home. If you don't believe me, that's okay. But you have to try it yourself. So that's at 10. And I'm going to move this hand from 30 in. And you can see that that hand will not move. You cannot move that until this hand gets to 20. Now, when this hand gets to 20, then both of them can move in. And you end up being at the 15. So the reason for that is that there's not much weight pushing down on this hand, so it's easy to move. The friction is very low on this case, but there's more weight pushing down on the 10, so it's harder to move that hand. So you can try this at home. It's good fun.